Okay, so we are moving on to Unit 3. It's nice and fast. Once you get the hang of everything, students tend to do quite well in this unit, which is good because it helps make up for those of you that struggle with the money management, which is the hardest unit. But a lot of you did really well, which is great. So working with graphs, some of this stuff you may know already, like you may have learned a bunch of it. So there's just certain things we want to look at. It's one sort of generally useful math skill to be able to read different kinds of graphs and to be able to make them. With technology now, we've got great tools for making really nice looking graphs. Microsoft Excel, which, you know, or any kind of, they're called spreadsheet programs. You can take a whole bunch of numbers and turn it into really cool graphs like that instantly. Even in things like Word processors, they have really nice graphing tools. So learning how to make nice graphs and how to read them is kind of a useful skill. Even just reading the news, you always see graphs in there. It's nice to be able to understand what you're looking at. Okay, but it's also a useful skill to be able to recognize when you're being deliberately misled. So graphs can be used and can be changed in ways that make you it's called biasing the information. So it biases it towards one way or another. And newspapers will do this. Sometimes you read the news, and depending on where the source is from, they can make the numbers look the way they want them to look. So actually learning how to read graphs better will help you understand separate fact from fiction, you know, truth and not the truth, those kinds of things. So whenever you have numbers, you can turn into some kind of a graph. The most common graphs are two-dimensional, and usually you're comparing two things. Okay? So, for example, this graph of Canada, usually there's a title on the top. This is a graph of the population of Canada. Usually on the bottom here, in formal math terms, we call the numbers across the bottom, we call that the independent variable, which means that's the thing. Usually it's like things like time, right? Time, years, those kinds of things. But then usually what's on the side here, we call this the vertical axis or the y-axis, is the dependent variable, which means what happens here depends on what's down here. And the main thing you need to recognize with graphs is you read them left to right like a book, okay? Especially when they're based on time. This one's based on time. So 1867, anyone know why they would use that year for the population of Canada? Yeah, that's when Canada officially became its own country, right? We call that Confederation, 1867. So they would have done a census then, which is when they actually try to count all the people, which is hard to do. But they figure it was around, it looks like 3 million people, right? Around there, a little bit more maybe. You can't tell exactly, but somewhere around there. And then the population started to grow pretty fast, right? So as you're going to the right, every year, the population of Canada seems to go up. And then usually with these kind of graph questions, they'll ask you questions about what's happening inside the graph. Okay? We call that interpolation, which means we look inside to try to figure out what's going on. And then sometimes they'll ask you, based on what you see, what do you think is going to happen in the future? Right? Like beyond the graph, we call that extrapolation. So over here, like if it said, what do you think the population is going to be in the year 2020? We would have to kind of extend this graph and say, well, assuming it keeps growing at the same rate we expect it'll be here. Okay? So we'll do those kinds of things. We'll look inside and outside. Inter, extra. And they could even ask you to go the other way. They could ask you, to go over here. What do you think the population was in 1800? You'd have to go to the left then. Be a little harder to do in this one, I think. Okay, so then you just have to be able to answer questions at first. What was the population of Canada in 1927? All you do is you always just go to your, whatever the independent variable is, and you just go up. So if I go to 1927 and then I go up to there, then I need to look across to the left to see what it is. Well, it's not perfectly on a line. It's somewhere between 7 million and 11 million, and it looks like it's a little closer to 11 million. It's pretty hard to eyeball it, so I would recommend using like a straight edge. A ruler is really good. So if you have a ruler, or anything with a straight edge on it, especially the ones that you can see through, they're great, because I can just like put it on there and slide across, and then I can sort of say, okay, it looks like it's closer to 11 million than 7 million, so I don't know, I'll call it 10. There's no, you won't get an exact answer. So when you're doing these questions and you look in the back, as long as you're in the ballpark of what it says in the back, then you've probably done it right. Okay? There's no way to know for sure. Definitely most people would agree that it's closer to 11 million than 7 million. Okay? And that's fine. So I just called it 10. You could call it 9.5. I don't know, whatever you want. Okay? Sometimes in textbooks in the back for those kinds of questions, it'll just say answers may vary in the back, which is really annoying because then you don't know if you've done it right. Okay? But as long as you're close. So B, what was the population in 1964? So there's that word. We must interpolate, which is to look inside. So 1964. So this one is even more work because I see 1957 and I see 1972. So where would 1964 be roughly between those 2 points? Yeah, it's in the middle, but if I wanted to be even more specific, if I had a ruler, I could kind of probably measure it out. How many years are between 1957 and 1972? 15 years? 15 years? So 1964 is 7 years past here. So it's almost perfectly halfway, but slightly to the left. So I don't know, if I was drawing it, I would just try to say, well, it's around there. And I'll just write in 1964. Again, with a graph like this, unless I was able to zoom in, like if it was on a computer, I could probably keep zooming in until I got a really accurate look at it. But this is not that great to look at. So then I'm going to go straight up from there. Okay, and it's kind of there, which is pretty close to 19 million, but it looks like it's just over it, right? So I don't know, whatever you want to call it. So it roughly corresponds to the point at which it's 19 million. So if you said 19 million or just slightly like above 19 million, that would be fine. Okay. And again, there's lots of room for error here, because if when you did your vertical line, yours was even just bent to the right a little bit, you'd end up with a higher point. If it was bent to the left a little bit, you'd end up with a lower point. So as long as you're in that ballpark, I think around 19 million is pretty close. Okay, in 1964. C, predict the population of Canada in 2012. So this is where we have to go extrapolate, which is to look beyond or look outside the graph. And that's where we actually want to draw. So what I'm going to do, these are going up by 15 years. So 2002 plus 15 makes what? Yeah, 2017. And if you have a ruler, try to make those spaces roughly the same, okay? The better you do at that, the more accurate you're going to be in your answer. So that'd be 2017. But we're looking at 2012. So where would that be between 2002 and 2016? It would be just slightly more than halfway between these two. So maybe let's put it around there, 2012. Which means I don't really have to go beyond this graph too much. I can just kind of extend this, assume it keeps doing that. And if I go up, it's going to be around there somewhere. Looks like when I did this last time, I was actually further over. Okay, whatever. So it's over 35 million. However you draw yours will kind of dictate it. In the solution key here, I estimated a population of 41 million. I think that's a little bit high, actually. I think it would probably be closer to 36, 37 or something like that. Okay? Whatever, depends on your drawing. And if it's a test or something like that, as long as what you say makes sense upon the way you drew it, that's fine. Okay? Unless I give you a really nice grid so that everybody gets the same answer, as long as you're close. Obviously, if you said 5 million, I know that you're way off, right? I know it's going to have to be over 35. If you said 100 million, that's also way off. So as long as you're between 35, 40, somewhere in there, that'd be fine. Does this kind of make sense for reading it? Okay. Just remember those terms. Interpolate when you look inside. Extrapolate when you have to extend the graph. Okay. Okay, so this kind of graph is, we just call this a line graph. It's probably the most common one you'll see. It's just a line that represents things. And sometimes line graphs are useful in that, like, you'll see it go up and then it'll go down, increasing, decreasing. And then usually what will happen in like a test question is it'll say, what do you think was happening when it dropped? Like, what do you think happened there, right? So if you're looking at, population of the world and you see between, 1939, 1945, the population of the world drops. Because normally the population of the world goes up, right? But if you saw in 1939, 1945, it went down a bit, you'd be like, oh, what do you think happened? Anybody know what happened in those years? War. Yeah, World War, right? World War. So one of the only things that can drop an entire world population down. Or maybe a really big like sickness, right? In the early, so 1914, 1918, you had World War I, which was the biggest one ever. But also you had, was it Spanish flu or something? Was wiping out millions of people. So then you would see, if you look back at historical data, normally you would see the population of the world increasing. But if you ever saw it go down, it would have had to have been some big sickness or a war or those kinds of things, right? Yeah. Okay. Why is that blurry? Okay. Example 2. Carolyn organizes her monthly expenses in a circle graph. Has anyone heard this called something else? Sometimes you hear it called like a pie chart, because it looks like pieces of pie, right? Pie chart. Same thing. Okay. They're pretty easy to read. They're really good for expressing percentages, right? So 50% is half. Like if you have 50% of something, that's half the pie, like half a circle, right? 25% would be a quarter of the pie, that kind of thing. So this is Carolyn's monthly expenses. You can't see it too well here, but it says that she spends 36% on rent. Is that normal? Do you spend about over a third of your money on rent? Yeah. In some places it's really high. Like if you live in like Vancouver, Toronto, people will spend like 75% of their money just on rent because it's so expensive, right? Utilities 12%, car payments 20%, savings 10%, food 15%, entertainment 7%. Depends on what stage of life you are. When I was a young adult and I just moved out on my own, like all my money was going to entertainment. Freedom. Okay. I just worked, and when I made money, I just spent it on stupid stuff. Okay. A, what percent of her monthly income does she spend on rent? You just go look at it. There it is, 36%. Pretty straightforward. What percent of her monthly income does she spend on food? There it is, 15%. How much does she save monthly monthly. Okay, now for these pie chart questions, if they're given as percentages, usually there'll be some kind of a number value somewhere, and up here you'll see she has a net income of $3,200. Anybody know what net income is? Yeah? What does that mean? Yeah, it's the money you can actually spend, right? Gross income is the money you can't spend because you don't get all of it. Some of it goes to taxes, employment insurance, CPP, Canadian Pension Plan. A bunch of it just disappears and goes somewhere, and maybe someday you'll see it. But net income is actual, like after not just taxes, after deductions, right? If you're lucky enough to have a job that's in a union, like I'm in a union, teachers union, so they take money as well, which not everybody likes, but feasibly, I guess they could protect me. If you all went and complained, the union would step in and say, eh. We're not allowed to strike in Manitoba. Manitoban teachers cannot go on strike. We have what's called binding arbitration. So places where public servants can't go on strike, they usually the government is negotiated for binding arbitration, which means they have both sides present their arguments, and then eventually it goes through this legal process, and the person usually cuts somewhere in the middle.
So you guys can't walk out?
We can't walk out. The only thing that teachers can do in Manitoba is, it's called work to rule. And basically what that is that teachers can, like, contractually, they're only contracted to teach like certain number of hours a day, certain number of classes, but then they could just stop everything else, right? This school is different because we kind of just teach, but you know, other schools, teachers are running clubs, or they're like, I used to coach sports teams, and they can just shut all those down, right? Which sucks, right? Like making school not fun for kids, right? Fortunately, that hasn't happened in a long time. What else? How much does she save monthly? Okay, so she saves 10%, so then all you do with percents is you multiply them, right? Whenever you have percent questions, they're always just multiply. 10%, you know how to do that, 0.10 times the 3,200, so she saves $320. Pretty straightforward for these kinds of questions. How much does she spend on her car payment? 20% times 3,200, $640. How much does she pay in rent? 36% of 3,200 is $1,152. Now Winnipeg, $1,152, I think that's still like, you can get a pretty decent place for that, I think. $1,152. Not in Toronto. $1,152, you'd be getting like a bachelor apartment. Like you won't even have a bedroom. Okay. Yeah. Winnipeg, as far as Canada is concerned, is generally as being affordable for housing, right? And people can, you know, if you get a decent job and you save up, you can buy a house here. It's pretty hard to buy in Toronto or Vancouver. Really hard.
Expensive?
Very expensive. Yeah, yeah. $1 million is nothing.
Especially Vancouver.
Yeah, Vancouver's crazy. But I mean, it's nice to be there. You know, just, yeah. Like here, we get nice places, and then we don't go outside for half the year, right? There, they just stay outside. They don't need much of a place if you stay outside all the time. You know, there's the island. You know, Vancouver Island. There's a huge tent city there. People just live in tents, right? It happens here, but in the middle of winter, usually it starts to disappear, right? Once summer comes, you're like, oh, there's a tent city. Okay, example 3. Used car sales versus new cars in Winnipeg. So this is just a line graph again. Sometimes you'll see they'll have different lines. Now, if you're looking at like something that's in colors, quite often you have a bunch of lines and they're all just color coded. Like this line means this. Like maybe the graph was like types, brands of cars sold in Winnipeg, and the red line is Toyota, and the blue line is Chevrolet, etc. You could compare graphs that way, right? This one is just comparing the year to the number of cars sold. Okay, and the number sold depends on the year. So if it asked you to sort of describe trends, that's a common terminology that you'll see. Describe the trend of the data. So what do you think's happening? Okay, this one is your used cars. What's happening? It's going down from the year 2013 to 2015, and then it starts going back up in 2016. And then if we compare that to the new cars kind of went up a bit between 2014 and 2015, and then it started to go down. Okay? And then maybe it'll ask you questions like compare, like this versus this, compare the data. What do you notice? If I compare these two things, what do you notice? Anything interesting? This is interesting here. What's happening there? The used car sales is going up, and the new car sales is going down. So then it might say, if you compare the data, you would say, well, in 2015, or the year 2015-2016, more people started buying used cars, less people started buying new cars, right? And so then it might say, why do you think that might have happened? Any idea? What might cause a lot of people to start buying used cars and less new cars? It's something to do with money, probably, right?
Maybe like the new cars got more expensive and like the used cars were like more cheaper, so people would buy.
Yeah, so one possible thing you could say maybe that year the price of new cars went up too much and people were like, screw it, I'll buy a used car.
Well,
right?
used cars are more cheaper than the newer ones.
Yeah, but that's normally true, but why would it be so significant in that year? So you'd say maybe the prices really shot up that year, right? Or you might have a comment about the economy. Maybe the whole economy, like everybody found that year really hard, right? Maybe that's the year the carbon tax came in, and everybody's like, I'm not buying a new car now. That'd be interesting. Next year, a year from now, to see what happens to car sales. Right? They might go down.
Cars have malfunctions too.
Yeah.
Recall.
Who knows? Maybe during that year there were a lot of calls of a whole bunch of different brands. So people said, I'm not going to buy a car this year, a new car this year, because they're worried about it, right? And that happens, right? Sometimes a car company will make 1 million cars and find out that they just made 1 million cars with a major flaw, like they blow up, right?
Or the airbags just automatically go.
Yeah, exactly. Yeah, you ever been hit by an airbag? Yeah. Yeah. I got hit by an airbag once I got in a car accident, and a guy got me out of the car, and I was completely stunned. He started talking to me. He says, "It's okay, buddy." He says, "You'll come to. You just got hit by an airbag." He happened to be an off-duty cop who was riding his bike by, so he knew what happened. But I was like completely out of it. I had no idea what was going on. Okay. So these are the kind of questions that asked here. In what year were the most used cars sold? You look for the highest amount, which looks like right there, right? 2013. Estimate the number of new cars sold in 2015. Okay, these are the new ones, the dotted line. I go back here, around 6,000. Okay, 6,000 cars. This is just Winnipeg, right? Could you make a prediction on how many used cars would be sold in 2017? So there's the used. And if I went to another year over here, let's call this 2017. If I extended that line, assuming it keeps going up, I don't know, it might actually go all the way up to like 9,000. That's, whenever you extrapolate, you're assuming that the trend continues. So if it's going up, just keep going. If it's going down, keep going. We don't know. We don't know. You're making that's the whole thing with doing predictions, right? Predictions aren't terribly useful. What did I do? All right. Example 4. A single line graph shows the average annual wages of bus drivers. Okay, so what can you, just looking at this, what can you tell me about the wages of bus drivers between 2010 and 2015?
They didn't make much.
Well, there's that. But what happened to the amount they made? It increased, yeah. They went from 25,000 a year in 2010 up to almost 27,000 in 2015. How can that happen? How can people's wages go up that quickly? How does that work?
Once you get like, usually people's wages go up by,
But this is for all bus drivers, so what do you think happens to make people's wages go up?
they have a raise.
Yeah, but why do they get a raise? Do companies like to give employees raises? They just said voluntarily do that?
No,
No, probably what happened.
the government.
No, the government doesn't want to pay more.
Oh, then I know. They want to strike you.
Yeah, so if they have a union,
They have a union strike.
which bus drivers probably do, they probably signed a new contract saying they needed an increase. And they did a good job of bargaining, right? They call that collective bargaining. Everybody gets together and says, we want better working conditions, we want more money.
Example from the day when the bus refuses to pick up people.
Yeah, exactly. So they could have gone on strike,
Yeah.
right? And
I
that's,
remember the bus weren't running because they were on strike.
yeah, there you go. So if you remember that, then clearly they have a union, right? And unions can quite often influence and bring wages up. Okay. If you are working somewhere where you don't have a union, usually small businesses, then you have to negotiate for yourself, right? So
It's like every man who does
kind of like, I remember working as a cook in a restaurant, and you have to know when you can leverage too, right? And I ended up, a couple people went on vacation. I was 16 years old. A couple people went on vacation, a couple people got injured, and next thing you know, like, I'm 16 years old and I'm the head cook of a large restaurant. And I was working like 80-hour weeks. And I didn't know labor laws back then, so I was totally taken advantage of. I was making like $4 an hour, no overtime.
So
Yeah, but I ate steaks. I knew I could get away with that. But they weren't going to tell me what I could and couldn't eat, right? I'm there all day. So, but at one point I was like, wait a second, I'm the only one here that knows what I'm doing. Had some part-timers. And so I went in and I said, you know, I'm working a lot of hours and you haven't been paying me overtime. And the boss was like, as soon as I said that word, he just backed up, right? I said, I think we should, you know, talk about it. I've been doing a good job. And then he says, I'll think about it. And then he called me back in and he gave me like a raise. It was still crappy money, but I just felt like I won something, right? So. And I used all that money. Guess what I used all that money for that summer?
video games?
No.
No.
It seemed logical at the time. I bought myself 2 Technics SL1200 MK2 turntables because I wanted to be a rap DJ. They were $650 each, and I paid cash for them. I couldn't even do that now.
That's cheaper than people, but
And then I just spin records all the time. And isn't that bizarre? But I loved it. I loved that stuff. Okay. Example 4. A single line graph shows the average annual wages of bus drivers. Describe the trend of the graph. So it looks like it's going up. Any of these words is good. Upward, it's increasing, it's positive. Those are all good. Whatever you want to say. It's going up. Predict the average annual wages of a bus driver in 2016. So if I went to here and I went up and I just extended that line up there somewhere, well, it's going to be over 27,000. I said maybe 27,500, 28,000 would be fine. What was the average annual wage of a bus driver in 2013? So if that's interpolation, if I go here, around just over 26,000. Okay. Is that okay? You're okay with reading these? Not too bad? Okay. Okay, example 5. The bar graph below. So this is called a bar graph because each of these is called a bar. Okay. And notice how they're separated. They're not attached to each other. Like each bar has a space in between it. We normally do those kind of graphs when there's no numbers down here. Like we're comparing things. We're comparing McWhoppers to Missy's Burger. Like they're titles, they're categories. Dogs, cats, fish, right? We don't. There's no numbers down there. It's not time. It's not continuous. You can use the word, I guess, if you want to use a mathematical word for it. You could say it's discrete data. Each thing is its own thing. So the bar graph below shows the prices of burgers at 5 different restaurants. So who sells the most expensive burger? Burgers are Us. I would not eat a burger from a place called Burgers R Us. Although I might be intrigued if the burger's like $12.50. Like that better be a good burger. Every year in Winnipeg they have that burger week. Well, all these places make a signature burger or whatever. I did eat like a $9 burger. It was I think it was $10 burger last year, and it was actually like really good.
Was that supposed to be Burger King mixed with McDonald's?
I guess they just made up the names, right?
Yeah.
Yeah. List the restaurants in ascending order. Okay, so this word you should probably know. Ascending means from smallest to largest. Ascend. Just pay attention to the A. I know with language it's hard to remember what each word means, but A is the first letter of the alphabet, so just remember that you're starting smallest and working your way up. Ascending, smallest to largest. So the smallest was Missy's, like it was the cheapest, just over $6, which still isn't cheap for a burger. McWhoppers was next. Just looking at the height of the bars. Okay. B, the price of a Missy burger is approximately half the price of which other burger? Okay, so the Missy burger's there. It's just over $6. Which one's almost double that, or more than double? It's that Burgers R Us one, right? So Burgers R Us is about, is almost double the price of a Missy burger. I shouldn't be doing these questions so close to lunch. C, which is more expensive, a burger at McWhoppers or a burger from JJ's Burgers? It looks like JJ's slightly higher, right? Yeah, slightly more expensive. D, estimate the price of the burger at Burgers R Us. So we said it's over $12, but it's not all the way to 13. So I would probably say around $12.50, maybe $12.50. If you said 12 something, just something a bit over 12, you'd be correct. You can't say 12 though, because it's clearly above the line, right? So if I'm marking a test and you say 12, well, you can see it's above 12. So you could even say, if you even said $12 and a little bit more, I would just say that's okay. I wouldn't like, because we don't know for sure, right? E, estimate the price of a burger at Mama's Place. So just over $8, $8.50 maybe, who knows? Okay, not too bad. Example 6. So this one, notice it looks a lot like the bar graph. Okay, they are bars, but they're attached to each other. Okay, and notice that they are represented, they do represent some kind of numbers. So whenever you can make bars that can be attached to each other, usually because it's continuous, like here it shows players' heights. Here's 173 centimeters tall or less, and then notice it goes right next from 173 to 178, then from 178 to 183. There's no gaps, okay? Then just think of it as like attached bars. It has a special name, and it's called a histogram. Okay. So it's for continuous independent variables. Otherwise, they do them the same way. Okay. In total, how many players are on the team? Okay, so to figure that out, how many are 173 or less centimeters? 2. How many are here? 5. How many are here? 3, 2, 3. So then you just add up all those numbers to figure out how many people there are. So 2 plus 5 plus 3 plus 2 plus 3. There's 15 players represented in the data. So that was a little tricky there. You had to actually add up the heights, because this is number of players, so you'd have to actually find. So you might have questions that'll do that kind of thing, right? Add up all those bars. How many players are between 173 and 178 centimeters in height? Yeah, 5 there. So you would say that that's the most sort of common height category for these particular basketball players. We don't actually have a basketball team, so. C, can you determine the height of the tallest person on the team? Can we figure out who that is?
Yeah.
No. It says the histogram shows there are 3 players that are at least 188 centimeters tall, but we don't know the individual heights of those players. Okay. One of them could be 200 centimeters tall. We don't know. Okay. If this was a 1, maybe, and if this was a particular number, but it's just a category, right? So we don't know. D, how many players are between 178 and 188? Okay, when that happens, you have to add up 2 categories, right? Because there's 3 here plus 2 there to get from 178 to 188. So that'll happen with some questions. So there's 5. And what percent of players are shorter than 178 centimeters? This one's not done. We got to finish this one. What percent of players are shorter than 178? So the shorter ones would be here. How many people is that? 2 plus 5. 7 players are shorter than 178 centimeters. So as a percentage, we have to add this here. I guess I should move that up. Whenever you get a percentage question, and it's one of the most common things students forget to do. That's why I'm highlighting it, saying pay attention to this. This will be on the test. As a percentage, you take your 7 players, divide by the total, which was how many? 15? Divided by 15 total players times 100%. So that you need a calculator for. 7 divided by 15 times 100, which is 40, let's round it off to 47%. So this is one of the most common errors I see on the unit test for this unit. It's always a 2-mark question. A lot of students they'll say 7 players. Total. Okay. And last example from this section. A recent survey was conducted about how many hats your classmates have. The table below shows the results. 17 students have between 0 and 3 hats, 8 have between 4 and 7, 3 have between 8 and 11, 1 has between 12 and 15, and somebody has more than 16 hats, which is messed up. Okay. A, how many students have 16 or more hats? You can just go in there and say just 1. How many students have between 4 and 15? Okay, so then you have to add up. 4 to 15 would be from here to here, which is 8 plus 3 plus 1, which is 12. What percent, careful, have 0 to 3 hats? You take your 17 and divide by the total, which is 30. So that's what we just did at the end of the last example. So 17 out of 30 would be 57%. Okay? So be very careful about those percent. Just remember, divide by the total. Everything added up. Okay? And D, state the percentage who have between 8 and 15 hats. So that would be here and here, which would be 4. And then you're going to take 4 divided by the total, which was 30. 13%. Okay, and this is an opinion here. What type of graph would best represent this data? So if you had those kind of categories, let's take a look. 0 to 3, 4 to 7, 8 to 11. So is that continuous or not continuous? It's continuous, yeah. So it's continuous, that's important. So I wouldn't use a bar graph because it's continuous, okay? Are these given as percent? No. Then it's probably, usually we wouldn't use a circle graph unless it was already set up as percents. And what else is there? A line graph. A line graph would be hard to do because of these categories, right? So which one do you think is the best? Yeah, probably this one, right? This kind? Histogram. So whatever it says here is wrong. It's not a bar graph, a histogram. A histogram would visually explain how many students own hats. Yeah, I don't even like the way that's worded. Histogram. Ignore the rest. A histogram, because of the continuous categories, that's probably the best one. Okay? You could make other graphs, but that would be the best one. That would be the best one. Quite often when people are doing things like PowerPoint presentations and stuff, which has built-in like making graphs, quite often you just make a bunch, and whichever one seems to be the best one to look at and to understand, that's the best one to use because they're fast to make. All right, how many of you have already done this assignment? Yeah. Was it okay? Not too bad? So I just wanted to really point out why each type of graph is what it is, and also those percent questions. That's the most important thing. And to introduce you to the terms interpolate and extrapolate, because those will come back on you later if you do further math stuff. All right? Any assignment questions that you want me to do? Were there any that gave you trouble or the answers didn't make sense? They're okay? There could be mistakes too. That's why it's good to always come back. Okay, if you haven't finished them yet, finish them. There's only a few lessons in here. There's a lot of questions. We're going to go through this unit fast, and you're all going to get like super high marks. So what?
I said, I just can't wait for you guys to get the book 4.
4 is